Good morning, students. Continuing to fifth unit, the next topics we are having is we are having the two more topics remaining in the next unit. That is with regarding to searching techniques. So, searching techniques, there are two types of searching techniques. That is, one is linear searching and one is binary searching technique. That is, linear searching is called as sequential search, and binary, the other one is the binary searching. So you know what is the process of searching? Searching is the process of finding a value from the list of values in the array. That is, we are having an array. An array contains, suppose if we are having 10 values in an array, from those 10 values we need to find our specific value to find whether the given value is present in the array or not. That is what the searching process is. So the most what are the two searching techniques that we have been representing at the start of this topic? The two important searching techniques are linear search technique and binary search technique. So coming to linear search algorithm, it is also called a sequential search representation. So linear search is searching for an element location by location, that is moving from first location to last location, finding whether the value is present or not. That is what we are doing is that is the process what we are doing with the linear search algorithm. With the step 1, what is the first step of the algorithm is to read the search element, to read an element from the keyboard. That is what is the desired element we need to read. And the second one is after reading the desired element, the second step is comparing that element with all the values in the array. And then third step is if any matching is found, then display that the value is found in particular array location and then quit from the process. If not found, then what we are doing is we will be repeating the process until we move to the end of the array. That is what we have been that is what is the process involved in linear search technique. So coming this can be explained with the following example. So these are the set of the elements we are having in an array: 13, 48, 7, 4, 15, 25, 11. These are all the elements we are having a list of elements in the array. Now what is the element we need to find in these arrays? We need to find the element 15. So what we are doing is we need to find the value 15 in the set of values. Now for that what we are doing is we need, what is the third step is we will compare the element with all the elements from the array. That is, in the first step we are comparing 15 with 13. So 15 not equals to 13, so we will comparing with 48. Again we will be comparing it 7. Again we will be comparing with 4. When reaching to 15, 15 equals to 15, the condition becomes true. Here the 15 equals to 15, the condition becomes true. So when that is where the value, where our desired value is found in the list of the array, where our desired value is found in the list of the array. So when our desired value is found, we will be quitting from the array, displaying that array the value displayed in first location, moving displaying that the value find at a particular location. What is the algorithm we are using here is there are two types of algorithms represented. One is algorithm algorithm in non-recursive manner, and the other one is algorithm in recursive manner. So in a non-recursive manner, what we are doing is so repeating for I equals to 1 to n, that is from first value to nth value. So when writing the program, we are taking it from for I equals to 0 to n minus 1. So for I equals to 0 to n minus 1, if k of I equals to key, k of I denotes the value in a particular ith location. That is k of I, k of 0, value in 0th location is equals to our key value. If the match is found, if it is true, then returning that position, whatever the position we are having, we are returning that position. If at all it is not true, again we are repeating the loop, moving to the next location. This is the process we are doing. Suppose if we move to the end, if we reach to the end location and we are not finding our desired value, then what we are returning is we are returning a value -1. So whenever we return a negative value, it indicates that the value is not found in the array. If at all we are returning a positive value, that positive value denotes the index of an array, and it represents array is found at a particular index. That is, the desired value is present in the array at a particular location. Now moving to the recursive process. What is recursive process is, we know the recursive algorithm. Recursion is nothing but call to a function within itself. Same, it is similar to non-recursion technique. There is no difference. So but what we are doing in a non-recursion technique, we are using a for loop, and then we are executing a set of statements. Now what we are doing in recursion is, whatever the process we are doing in non-recursion, that entire process is made as a function, and we call that function repeatedly. See here, if n equals to 0, then return -1. So what is n is, we have been founding the location. If at all we are founding that is the index, whatever the index we have been taking, with the n is considered as the index. If n equals to 0, then return 1. Else initially n will won't be 0. Then what we have been taking, so n is nothing but the size of an array. N is nothing but size of an array. If n equals to 0, then return 1. Else what we are doing is, we are comparing it with value k of n equals to key. That is, k of n is, that is the k of 0th location, k of first location, k of second location, k of third location. Like that we are been considering. So n is the index of an array. We are comparing index of an array. We are taking the index of an array and comparing the value in that index with our desired value. This is what the recursion process is. So what is this recursion process? This is the function. See here, this is the function we are having. Recursion L search of k is an array n minus 1 comma key. So first n minus 1 file, we are having 5 array indexes starts from array index starts from 0 to 4. So n minus 1 is 4. So array fourth location key value. Now we start, that is, we start the process. K of n equals to key, that's k of 4, k of 3. Again first we start with 4. So then k of 3, then k of 2, then k of 1, then k of 0, then k of, so like this we will be repeating the process, comparing the value, comparing each location value with the key value. So this is what the recursion technology. So analysis of linear search. What the analysis is? Analysis is nothing but the complexity. To find the complexity of the linear search. What is the complexity of the linear search? We have been representing the worst case, average case, and then various notations we have been representing. So in each and all the cases, what is the time complexity is? It takes order of n. That is, it represents the size of the how many comparisons. If one value, one comparison, two comparisons. If I am having 100 values, 100 comparisons, that depends on the n, order of n, that depends on order of n. So it is called as an order of n. So there are different types of linear searching notations. Those are called as, probably called as, what are the different notations is variations of linear search or different forms of linear search. One is sentimental search, and the other one is probability search, and the other one is ordered list search. What is sentimental search is the target element and the last element of the original array. We will be representing the key element, and we found the actual data for the sentimental. So this is actually this topic is not within our syllabus, but remember what are the types of searching techniques, various types of linear searchings we are having is, we are having a sentimental search technique, we are having sentimental search technique, and then we are having probability search technique, and then we are having ordered list search technique. Then we will be moving to binary search. So after to the linear search, the next concept we are having is the binary search. What is the binary search? What is the difference to linear search and binary search? So both the linear search and binary search are used to find the desired element in the key value. Sorry, both are used to find the desired value in the array. Linear search will compare starting from 0th location to nth location, whereas the binary search, where the comparison will be done only in the half of the array. So what happens with the binary search is, all the elements will be in sorted order. In a binary search, all the elements will be in sorted order. So now such that what happens is, now we take the mid value. What is, we take the mid value from the array, we compare with the we compare with the mid value. So if the, suppose if we need, it's a similarly in the previous example we are having, in the example, this is the example we are having a 12 such a, we are having the list of elements. We need to search for an element 12. Now from this what we are taking is, we are taking a mid position value, that is 50 is the mid position value. So now what we are doing is, now we compare 50 with the 12. If 12 is less than 50, then the value will be, the value will be allocated between the value that that is the value 12 lies between 0 to 50. If the value is greater than 50, then the value lies from 50 to n position. That is, as the elements are, as the elements of an array are arranged in sorted order, now whatever the value we need to compare, that value lies either in the first part of the array or the second part of the array, or it may be a mid value. If these three cases fails, then the value is not found in the array. So for that what we are doing, we are comparing it with the mid position. If the value is less than mid position, the value lies from 0 to mid position. If the value is greater than mid position, the value lies from mid position to the end of the array. If the value is equal to mid position, then the value lies at mid position. That is the process we are doing here. Now when compared to the time complexity of linear search and binary search, what is the time, how the time complexity is reduced here? The time complexity is reduced by half, where we are not comparing the, where we are not represent, we are not follow, we are not indicating, or we are not representing the comparisons to the entire locations of the array. We are, now we are comparing only half of the array. Now we are comparing only half of the array, such that the time complexity is reduced when compared to the linear search technique. So this is an efficient searching process in the linear search. So now coming to the analysis, what we have been representing in a sequential search, we are having order of n. In a binary search, it will be reduced to half. The number of array elements is reduced into half, so it will be, or so it will, so the number of elements is reduced to half. See, this is array size, how many comparisons we are doing in linear size. So the linear binary search is order of log n. So if an array size is 16, linear search, what are the maximum comparisons? We need 16 comparisons. In a binary search, 4. That is, it limits to half of the, it limits to the half of the comparisons when compared to the linear search. So we will be using the binary search technique in order to represent, in order to find the desired value in the array. So with this we conclude these searching techniques, and with this we conclude the 5th unit. Thank you. I will be revising the topics again. Thank you.